The following presentation was recorded at the Menditto Amplification Annex of Maggio Music Center in Brooklyn, New York. Welcome to the workshop. Today we are working on this Hartke Systems Model 3500. This is a 350 watt hybrid tube and solid-state rack-mounted bass guitar amplifier. This amplifier features one 12AX7 tube in the preamplifier section, as well as a solid-state preamplifier section. You can use one or the other, or you can blend them both together. The power amplifier section features 8 complementary NPN and PNP Toshiba output transistors arranged in a Class AB push-pull configuration. This amplifier was brought to me because it blows the main 8 amp fuse as soon as it is replaced and powered up. I have already successfully diagnosed and repaired the problem, so now I am going to show you how I approach this from start to finish. Okay, I am just going to start off by telling you the diagnosis of the problem. We have 2 bad power transistors, and you can see that there's one missing from here, and that's this one. And on the opposite side, this is a heat sink with an air channel that the fan blows through to cool it off. And on the other side, you have your green bank of 4. So I don't remember which color is which, but you have a bank of NPN on one side and PNP transistors on the other side, and they work together in a push-pull configuration, and that's how you achieve 350 watts of output power. Now, the way I determined this was as follows. Now, I already had a suspicion that this was the problem because I have worked on many of these amplifiers before, and this is a common problem. However, the way that I went about this and started out was unplug your power transformer and you change your fuse. You don't turn it on until you unplug this, and then you start it up with this unplugged because this is taking away the power from the main circuit board and to the power amplifier. You also want to be very careful because this is 2 relatively large. These are 4,700, 4,100. These are pretty large electrolytic capacitors, and you get a nice shock out of that. So if you did already turn it on, you might want to take a ground lead and short it out here and make sure that you have made this safe. However, you disconnect this, you plug in your power cable, and you start the amplifier up to determine whether or not you have a problem with your power transformer. Okay, you plug that in, this worked fine, so the problem is not with your power transformer. So now you want to disconnect your power amplifier section here and then plug your main board back in. Now you're going to, in between doing that, you want to unplug your power just to be safe. Now you plug your power back in, and then what you are going to do is you are going to plug the send from the effects loop into, with an instrument cable, the regular guitar cable, you're going to plug that into an amplifier that you know works. Okay, this instrument cable goes into another amplifier that we know works. So we are going to plug this into the send from the effects loop on the back of this unit. Now, turn the amplifier on, fan goes on, plug this into the passive input, and look at that. Preamplifier works. So now you saved yourself a lot of diagnostic time. We know that the preamplifier works, so now we know that the problem is in the power amplifier section. I have removed the power amplifier unit from the amplifier, and it is out on the workbench here. I am going to explain to you how I determined that this transistor is bad. You need a multimeter. You put it on continuity mode so that when you complete the circuit, it makes a tone. All 4 of these transistors are in parallel. So each one of these 3 terminals is connected together amongst all 4 of them. And I will demonstrate. Connected to the base here, and when you touch the base here, and the base over here, they are all connected. Okay, the same with every other terminal. Collector, 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 and just for good measure, emitter, emitter, emitter. So I pulled this one out of the circuit first, and the condition still remained that there was a direct short between the collector and emitter on all of these. And you will see, if you start with the base, not shorted. But if we connect it to the collector is directly shorted to the emitter. So if we put this back into the circuit, like this. Okay, this is back in the circuit. Connected to the base over here. And that should be, yes, connected to the base, base, base. But there's no continuity to the other terminals. But now if we connect this to the collector here, and the collectors are all connected together as we determined before, but now we have a direct short everywhere between the collector and the emitter. So I will demonstrate that when I remove the emitter, now we no longer have a direct short, so that this entire bank was shorted between the collector and the emitter because of this one shorted power transistor. So I removed this one from the circuit first and the condition remained, and then I got lucky and removed this one after that, and then I realized that this is the problem. Now you can test voltage drop. If you look up how to properly test a transistor, you could put this into diode mode and then you can measure forward voltage drop. There is a procedure with which polarity you connect to each and then what the voltage drop should be approximately. That's not necessary in this case because we have determined that this is indeed bad. I'm going to flip it over to the other side and show you that this one, same thing. Not shorted, but then the collector, forgot to put it back in continuity mode, direct short. Right, base not shorted, but collector and emitter directly shorted together. See that on this side here. So here I removed, I think I got lucky on the first shot with this side. No, I think I removed this one first and then determined that this was not the one that was shorted, and then second try I did it on this one here, and that ended up being the problem. So do I need to set this all up and show you that again? Well, Let's go bass. Nothing shorted. That's parallel. Parallel here. Parallel here. Nothing shorted. Okay. Parallel. 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 Okay. Nothing is shorted. Just the one that's in parallel together. So if we take this and connect this one back into the circuit, and since they are in parallel, it'll be easier just to go right there. Okay. The same thing as connecting it to the pads in the vacant spot. Let's make this a little bit neater like this, and then like this, and go right here. Okay. Now, this is the bass. Bass is not shorted, but then we go to the collector, and now we have a direct short between the collector and the emitter on each spot. So again, only one bad transistor, and now the whole bank is shorted out because each one of these is arranged in parallel. So now what we are going to do, just to show you that this was the cause of the direct short, with just 3 power transistors on each side, we are going to plug this in to the amplifier and see if it works. See if it blows a fuse immediately, and see if it powers up and actually works. Let's go put it back in. Okay, we're on the floor. The only speaker capable of handling the power that I have right now is across the room. So we are going to plug this in. Okay, the power amplifier has been mounted with just 2 screws, but it's mounted nice and stable and securely. You do not want to accidentally short any of this out against the chassis. That would be catastrophic, and it would be completely counterproductive to everything that you were trying to do to repair this amplifier. So before, with the shorted out transistors, 1 on each side, this unit would blow fuses immediately as soon as you turned it on. So now we should be able to turn this on and it will run, and then we will connect an instrument cable, turn the master volume down a bit. We've got our preamplifiers up. Okay, turn it on. We did not blow the fuse. It works. I heard a sound like something powered up. Okay. The amplifier works. So that the 2 shorted power transistors were indeed the problem. Now, I'm not sure if this is a good idea to keep it running like this. So we've tested it out. We know that it works, and we know that the problem with it immediately blowing the fuses and not making any sound at all was indeed 2 directly shorted power transformers, 1 on each bank. Okay, I have already installed our transistor into place. When you do this, you need to screw it in to place, and you need to replace these silicone heatsink pads. This pad is insulative, where it electrically isolates the back of the transistor, because if you look, it is metal. So it electrically isolates the back of the transistor from the heatsink, and it also aids in, it's thermally conductive and aids in transferring the heat directly into the heatsink. Other thing we need to mention is that you should heatsink each one of these legs as you are soldering them. So you take an alligator clip and you put it there before you solder it into place. Now ideally you would like to be able to pull this out, this whole circuit board out, and solder these into place, but the chances are that you are not going to have this aligned perfectly, and you're not going to be able to screw that into the heatsink. So it's better to do it like this. Now after you have soldered it into place, you need to come in with a magnifier or something and look very closely and make certain that you have not shorted these pads together. So as you can see, it's good. I gently scraped out some of the flux just to make certain that these were not connected together. And now I am going to follow up with this little brush. This is like a intradental brush and some 99% isopropyl alcohol, and I'm just going to clean these all. Even the ones from the factory are a little messy. Going to clean them all, and then I am going to check with the multimeter and make certain that nothing is shorted, and then I'm going to install this back into the amplifier and try it out. Okay, everything is all cleaned up on both sides. Made certain that nothing is shorted together, and I cleaned up all of the flux, even the flux that was left over from the factory. Okay, that's very important. The last thing that you want to do at this point is to create a short and destroy this unit. Okay, we are going to test this with the multimeter, make certain that there's no shorts, and then we are going to install it back into the amplifier and try it out. We also want to make certain that everything is in parallel like it's supposed to be. So start here. That's our base. Make sure we are on continuity. Base, 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 all connected together. No short. No short. Okay, our base is not shorted. Collector. And it's redundant to keep trying every spot, but might as well. Okay, collector is connected there, connected there, connected there. Not shorted anywhere. It's connected where it's supposed to be. And then the emitter. Emitter, 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 emitter. All connected the way they're supposed to be. Got a helicopter flying overhead again. It's probably the NYPD. Probably looking for somebody. Okay. Flip it over. Connect it to the base. Base connected everywhere. Yep. Exactly the way it's supposed to be. No shorts. No shorts. Got some activity going on out there. It's life in the big city. No shorts. Collector is connected like it's supposed to. Collector, collector, collector. No shorts. go to the emitter. Emitter. Connected. 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 No shorts. So we are good. Now we are going to reinstall this into the amplifier, and then we are going to try it out. The last thing that we need to be concerned about is that if you look here, this is a trim potentiometer, and this is a trim potentiometer. You can bias this unit. This is an AB amplifier, class AB. So there is a tiny bit of overlap to make sure that the signal is smooth, and you can adjust your bias to make certain that there's not crossover distortion and there's not kind of a dead spot where it just doesn't sound good, where it's not conducting smoothly the entire waveform. So we need to find the procedure on how to bias this, and that might be challenging. But ultimately what we are going to do is first we are going to install this into the amplifier. We're going to listen to it to see if it sounds good, and then we are going to hook it up to the oscilloscope and then just see if the waveform looks good. I was unable to find official documents with information about biasing this power amplifier. I did find some comments on message boards saying that you need to measure the voltage in millivolts between test points 1 and 2. One post said that the voltage range should be between 20 and 25 millivolts, while another post said that it should be set at 36 millivolts. And yet another post said that the range is between 19 to 34 millivolts. One post said that the lower trim potentiometer, SVR301, adjusts the bias, but another post said that SVR301 controls the DC level of output and that SVR302 controls the bias. I found that the voltage changed between the two test points when SVR301 was turned. I set my oscilloscope to DC coupled mode, and I did not see any change in the output when turning SVR302. I set the voltage between the two test points at about 22 millivolts. It was at over 40 millivolts when I first measured it. I do not have a speaker or dummy load here that can handle 350 watts of power, so I am going to leave this set at 22 millivolts. The guys at the store will be able to give this a sound test at full power. I will make a follow-up video if they determine that the amplifier has any performance problems. Thank you for watching. Please like this video and subscribe to our channel. Please also leave a comment below. Comments really help to bring more attention to our videos. If you have an instrument or amplifier that needs repair, you can send me an email or give us a call at the store.